David,
Yes.
are we going over derivatives this semester
Oh,
or?
no. Derivative is in calculus one.
Okay.
Yeah, derivative, limits and integrations are all in calc one. That's what you will learn. So, and that's where you start to do all these derivative and integrations of, sine, cosine, and tangent, and all those things. And in order for you to do that, you have to apply your trick and identity. So
Okay.
all those identities that you learn in chapter 7, you'll be applying that in that class. So that's the reason why that you at least seen it, and at least you know what to do with it. So first thing first is that yes, I'm back. So I'm still a little bit slow. The medicine is a little bit strong, so it's just a bit slow for me. And that's the first thing is. Second thing is your test. So your test is next week. It does consist of chapter 7.4 and 7.5. So remember when you come back from spring break, we did two sections of the last two sections of chapter 7, and then chapter 8, which we will be finishing today, which is till 8.6. We don't do 8.5. Your test is next week. It's gonna be a take-home test. As you know, it's a take-home test. It's an open book, open notes. So I don't know what you're doing. However, the test is posted at noon next week, and you have 4 hours to do your test. That means that till 4 p.m. you will have to upload that to D2L as like usual. I do let you guys do multiple upload nows, and I do also let you guys do re-uploads till 4 o'clock. That means if you upload something else you want to re-upload again, it's fine with me until 4 o'clock, and that's it. Okay. I would really strongly suggest to use your cam scanner. I know some of you take pictures of it. I will still grade your tests, but there will be no corrections in this time. Students with accommodations, you will get the extra extended time. So that means that if you're asking for 1.5 time, so you have actually 6 hours to do the test. So that means you go up to 6 p.m. I would strongly suggest you guys to print out the test. Please write your name, because I still have students who do not write your name. I don't know why. This is the kindergarten first thing you learn, to write your name on anything. So please write your name, and then I do need show work. So this is the most important thing about this, because it's a take-home test now. So you have to show work. And if a work that comes from calculus 1, yes, I have students try to do works that from calculus 1. I will look at it and see if you know what you're doing, then yeah. Then I've been kind of asking you was like, why I'm using calculus 1 here to show me your work? We are in pre-cal here, right? So I do have students that, so I will still look at it, and I will wondering like, who teach you this? That's my next question for you. Or who is doing this test for you? So again, I know what is going on, and 4 hours is not a lot of time, actually, I can tell you that. So please do yourself tests. Okay, that will tell you that. But you can have your books, you can have your notes and anything. So at the end of your test, you also get that the chapter 7 formula. Remember the 1-page formula? I also attach that formula at the end of the test here. So does anyone have any questions about your next week? There will be no Zoom next week since the test, but I do want you guys to do a little bit of reading of chapter 4, which is the connect section. So I will let you guys know once you finish the test, because your test is on Tuesday. So on Wednesday, I will put in some videos you can watch in this case. Then we talk about calculus 1. We did not do integrations and differentiation and limits here. That is all in calculus 1. So what we're going to do in next chapter, after you finish your next test, your next chapter will be consist of conic section, and also see a bit slow. Not limits, sequence and series. So we talk about geometric sequences, arithmetic sequences, and series. Those are not difficult, actually. where we are not, and also we're doing a binomial theorem in this case, which is important. So those are the few things that I will stress on. We will not be concentrating on doing sine, cosine, tangent after chapter 8. And your final is only consists of these two parts, the conic section part and also the series and sequences part. So there's no chapter 6, chapter 7, chapter 8 material. So your final is just chapter 4 and then chapter 11. Okay. Anyone have any? Oh, no, this is downhill. Once we finish this, everything is downhill. Conic section is a little bit hard, but series and sequences are like super easy. Okay. Mostly, I can tell you that mostly the last 2 chapters that I mentioned just now is very heavy on formula, but if you know your formula, then you'll be fine. Okay. Anyone have any questions for me? So as someone pointed out, when you do vectors in 8.3, do not use your IJK letters in your keyboard because they won't take it. Because your IJK is just a normal IJK, so it has to be bold. So when you do your homework, make sure you put in that the right hand corner. When you click on it, there's something pop out like when you put the infinity symbol. There's one little thing called vectors. So that is the IJK, UV, all those things. Please use that. Also in 8.4 and 8.5. Okay. Yep. Those. No, you do not need to worry about those students with accommodations for your test. You just need to do your test as usual and then upload it till 6 o'clock. You are 6 till 6 p.m. So you do not need to worry about just do like normal tests and then you have the 1.5 times accommodations. No. So the extra time is extra time. So you got till 6 p.m. That's it. If you want to upload your test earlier, it's fine with me. Okay, but you have up to 6 p.m. So let's take a look. Anyone have any questions on 8.3 homework? Just to be know that.
Question 31.
I'm sorry. So can you?
Could you go over question 31?
31. Okay. So let's take a look at 31 here. Again, I'm a bit slow today. 31. Okay, so this is something that I will point out again that you do not have to worry. We will use a formula today to do this question, which is like way simple. So we'll do 31 here. So this question is actually called us to use law of cosine to figure out this angle alpha, which is between 0 to 180 degrees, where vector v is I plus 3j and vector w is 3I minus j. So for those people who first know is vector is actually correspond to 2 important stuff, the directions and the magnitude. So if you doesn't know what is a vector, just draw it out. It's like a coordinates, but this time you just have arrows like a ray. So vector v in this case is I. So usually I is your x and j is your y. So what 1I plus 3j. So this is like coordinates 1 and 3. So this is actually is vector v. Okay, and then vector w is 3 and negative 1. So 3 is here and negative 1 is here. So this is vector w. So they want you to figure out what is this angle is. This is angle alpha. Okay. So in order for us to do this, we just need to figure out a triangle. So one thing I want to point out to you guys is when you add vectors, your arrow has to go smoothly. Like sometimes, like if you have a vector that goes this way and you have a vector goes this way, like what we have here, you have to your addition vector here was going down this way. But since the arrow doesn't follow the same, the arrow follow the same means it should go something like this. This is what we call as it follow the, so if this is u, this is v, this is u plus v. However, because of the direction of this arrow goes in a separate way, so you have to go in one of, you have to switch one of this direction. So that's why this vector v, the other, let's do it. Yeah, it doesn't matter. So this vector v, instead of vector v now, this because it's going the opposite direction, so it's going to be a negative v. So this is actually is w minus v. Or you can do it the other way around, where this is so you go v and then a w, and then this is go this way. But the best way is you flip it around. So usually, in order for us to figure out the third line, so that you draw a rectangle, this is actually is v minus w. So that's how they found the third vector is v minus w. And so in order for us to do this, you simply subtract your corresponding ij. So what is v minus w in this case is you take 1 minus 3j, which will give you negative 2i. And then 3j minus negative 1, so that would be a positive 4j. So this is how you how they figure out the vector for this what we call as a resulting vector. So they just simply subtract this. The reason why they subtract is because of the direction of this. Should we go this way? So next thing you need to do is, because in order for you to use law of cosine, you need to figure out the length, because law of cosine is SSS. So you figure out the length. Length in this case means magnitude. So if you figure out the magnitude for the vector v, so magnitude is actually the distance formula. So you just take the square root of the first component square plus, like a Pythagorean theorem. So a square plus b square, and then take the square root. So 1 square is 1, 3 square is 9. So 1 plus 9, this is 10. And then if you look at the w, you do the same thing. So 3 square is also 9. And then 1 square is 1. So 9 plus 1 is root 10. So this is square root of 10. And then the last one is the v minus w. So again, in order for you to find the magnitude of this, you just square this 2 and then square root it. So square of 2 is 4. 4 square is 16. 4 plus 16 is square root of 20. So now you guys got yourself what we call as a triangle with 3 sides. Root 10 on this, root 10 on this, root 20 on this, and the alpha, don't forget, we are looking for alpha here. So I'm just convert this into the into triangles. So so now we can use law of cosine. Cosine alpha is this square, the one that takes my is the 2 of this square minus the one that is him. So square root of 10 square plus square root of 10 square minus square root of 20 square is a square plus b square minus c square over 2ab. You notice that when you do the top one, you get what here? When you square this plus square that and minus square of that?
0.
You always get 0. Yeah. So this question is special because no matter what question you do, this question will be 0. And 0 divided by whatever number you have, you still get 0. So can someone tell me what is the arc cosine of 0? Anyone?
0? And
I think it's 90 degrees, right?
oh, is it 90 and 3 pi over 2?
Yeah, but again, we want it in in degree. We don't want it in radian. So I think it's yeah. Sorry again. Yeah, it's 90 degrees. Yeah. So again, they want it in degrees. So your answer here is 90 degrees here. Now again, class, this is a very, very difficult way that I showed it to you. I mentioned that the coming up section, today's class, you will learn a shortcut, and that shortcut is like this, okay, which I will teach you now. Okay, so so this is how we do this question. So the shortcut, this is the shortcut. So in this, this is 7.3. So in 7.4, okay, so this is what you will learn in today's class, 8.4. Again, I want to point out again, I'm going to be a little bit slow today. So the 8.4 sections that we talk about here is called the dot product. And this you see, I kind of highlight this. This is where you find an angle between the two non-zero vectors UV. It's where you do the dot product of u dot cosine of theta is u dot v over by absolute value of u. Absolute value of v means the magnitude of u and v. So first thing first, I need to figure out what is a dot product. A dot product is where you take two vectors and you dot it. We don't call it multiply, we just dot it. What you do with this dot product is you take the first two components, you multiply it, plus you multiply the second two components. And the result of this is a scalar. A scalar means that it's just a number. It's a 6, 8, 9, 1/2, -2, 5, whatever. It's a number. So it's not in a vector form. Okay. The dot product has a few properties, like if you do u dot v is the same thing as v dot u. If you multiply 0 with any vector, dot it with any vectors, you get 0. It uses distributive property. So u dot v plus w is the same thing as u dot v plus u dot w. If you take the same vector and you dot it by itself, so v dot v is actually the magnitude v squared. And if you take a constant c and a scalar c and multiply with u dot v is cu dot v or u dot cv. So I'm going to tell you what's going on in this dot product. So as you guys mentioned, as you guys know that, so this actually is the same thing as cosine theta, u dot v over by the magnitude of u multiplied by the magnitude of v. So this question that we have that you guys asked me, so this is, let's say this is u and this is v. So when you dot these two up, dot means you just take their i's, multiply it, the numbers in front of I. So 1 times 3, you get 3. And then you take the j's and you multiply them. So 3 times -1 is -3. So you simply multiply your i's and your j's numbers out. And then over by the magnitude of u. Magnitude of u means is the squaring a and b squared, and then you take a square root, which is square root of 10 in this case for the first one. And then the next one is if you square, this is also a square of 10. Again, what you get in this case is also a 0 because 3 minus 3 is 0. And as I mentioned, 0 over anything is 0. And don't forget, this is exactly the same as what we have done early on this side, where cosine theta in this case is 0. So that's why theta in this case is 90 degrees. So you do not need to find the v minus w that we just did here. You do not need to find all the length of it and then use the law of cosine to figure out your theta here or your alpha or whatever it is. So so that's the reason why that this is the quickest way to do it. So this formula that you see here is the formula to find an angle if I give you two u and v. Okay, so that's the quickest way for us to do it. Okay, what is so important about this dot product here is that if you find out these two dot products are equal to 0, you find out that these two vectors are orthogonal to each other. So orthogonal means perpendicular. So that means if in order for you to figure out, if I want you to prove that these two vectors are orthogonal to each other, you just need to multiply that. And if you got something like this, where when you dot this and you get yourself a 0, then yes, these two are orthogonal. Orthogonal means that they will meet and they will form 90 degrees in this case. So so what happened is this these two vector v and w orthogonal? I will say yes, because the dot product of that is equal to 0. So that is the meaning of the word orthogonal. U dot v equals to 0. I'll give you some examples so you will see what's going on with this. Okay, so so mostly in the test, please don't use a law of cosine to do it. Use the dot product to do it. That will be the fastest way to find your angles. Okay. For example, here is number like 7 here. It's given us that u is 5, 7 and v is negative 2, 5. This question wants you to find the dot product of this. So what you do is you just take the first component, multiply it, and add it with the second component, multiply. So first component multiply here is negative 10. Okay, so the first component, when you multiply this 5 and negative 2, you get negative 10. And then multiply the second component, 7 and 5 is 35. And you give me, your answer is a number. So 35 take away 10 is 25. So your answer here is just 25. That's it. It's very easy for this. Then usually in the test, I will ask you, is u and v vectors orthogonal? Since this is not equal to 0, it is not orthogonal. Okay. Can someone do question number 8 for me? U dot v. This is very easy. You have your calculator. And main part is there's no IJ form here. It's just a number. Anyone? What is u dot v in this case?
Negative 12.
Yep. And it can be negative, so that's it. So 2 times 3 is 6, and then 3 times negative is negative 8, and then you just add them up. So that's why negative 12. If you have a number in front of it, you just do the same thing like this, and then you multiply it by 3. Okay, so you do the same thing. Okay, u dot v is negative 12, for example, like here, and then you multiply that number by 3. So sometimes when you multiply with something else, your answer can be a vector and your answer can be a scalar. How do you know if your answer is a vector or scalar? It depends on your answer. If your answer is just a whole number like 12 and all these numbers that we just mentioned, it's going to be scalar. If a question has like the vector form like 3, 2 or like the less than greater sign in vector form or IJ form, then it's in vector form. So for this question, it's going to be in scalar because when you take a number multiply, when you take u dot v, which is a scalar, multiplied by a 3, you get a scalar form. But if you notice this, does anyone know what happens when you take the vector v and you dot it with a 0? The formula says that if you if you dot it with a 0, you end up with a 0. So what happens in this question here is if you dot this with a 0, this end up with a 0. And do you know what happens when you take a 0 multiply with a W vector? So does anyone know what happens? So we know that
You did 0.
you get 0 or you get the vector 0, 0. So my question is, will you get 0 as a scalar or 0, 0 as a vector?
0 as a scalar.
Okay, so we know this is a 0, right? The v dot 0 is 0. We know that. So if you take 0 multiply with the vector w, and what is the vector w in this case? The vector w in this case is 3, -2. So actually you end up with the 0 as a scalar form, or you end up with the 0, 0 as a vector form.
Vector form?
Yep, because when you multiply the 0 inside, you actually end up with a vector form. So this answer, you should have 0, 0 in a vector form. And it is a vector in this case. So just want to tell you that these two are different because this 0 means it's a scalar. And then this 0, I'm again, today I'm a little bit slow. I want to point out to you guys that it might be a 0 that someone mentioned earlier on. Yep, okay, this is correct. Okay, again, I want to tell you that I might be a little bit slow today, so so I just want to point out to you guys. All right.
I wrote in just 0 without the vector, and it still gave me the right answer too.
But if you pick the scalar form, do you get it right?
I chose scalar, it's wrong, but when I write the form, just number 0, it's
because 0, 0 is, if you give me 0, this 0, 0 is also the same thing as 0. But this 0 is a vector form. That's the main part that I want to bring it up to you guys, that 0, 0 can be written down as the number 0, because if you draw the vector 0, 0, it is just a point, which is 0 in this case. So that's the reason why. And the main part of this is they want you to figure out, is that a vector or is that a scalar? Okay. Does anyone know what is this line stands for, the two lines with the U?
Magnitude?
The magnitude, yes. So we just did it just now. And how do you find the magnitude of U in this case?
You find the distance between the two dots.
So square root of what?
4 squared plus 4 squared.
Which is?
4? No, wait. 4 squared plus 4 squared. Square root of 32.
Yeah, very good. And make sure you reduce this root of 32. Anyone? Reduce root of 32.
For the square root of 2.
Very good. And since you just have a 2 minus in front, so I'll put 2 minus in front. So your answer in this case will be 2 minus 4 root 2. So this is your answer for number 11. The main question is this a vector or is this a scalar?
Scalar.
Again, because magnitude is a scalar. Okay, magnitude is a scalar, so it's S. So magnitude is a scalar, so that's the reason why that 2 minus a scalar will be a scalar. So this will be a scalar. You guys all right? This is pretty much easy. This is the same thing. You dot this, and then you dot this, and then after that you subtract that. Okay. Does anyone can tell me when you dot this, is that a vector or is that a scalar when you dot these two?
A vector.
Don't forget, every time when you dot something, it's always going to be a what? Yeah, it's going to be a scalar. So, so I want to point again that if you dot v dot u, you will end up with having a scalar. And then if you do w dot v, you end up having a scalar. So if you subtract these two, you will end up also with a scalar. Okay. Next, they want you to figure out the dot products to use a dot product to find the magnitude of u. Just ignore it. I will tell you, just find the magnitude of u, like the same thing I teach you just now. Just take the square of this and square of this, like what we just remember how we find the magnitude of u. So don't do the dot product. It's just a little bit of work. So I would recommend you to just use the square root of a squared, the first component plus the second component square. Okay. Next is this. So this question wants you to find the angle. So again, in order for us to find the angle, you have to use this formula. This is the formula you need to. So that's the reason why these two formulas I highlight in yellow means that you need to know this in your next test, 12 next week. So so every time the question asks you to find an angle, so you have to use cosine theta equals to u dot v over by the magnitude of u times the magnitude of v. So this is the formula that I will really want you guys to know. Very important. So so this question wants you to find the angle between these two formulas, between these two vectors, 5, 2, and 3, 0, and it must be in radian. So make sure you guys change your calculator back to radian. So first thing, in order for us to find this, do the u dot v first. So anyone know what is u dot v in this case? So 5 times 3 is 15 minus what? 0. 2 times 0 is 0. So 15 minus 0 is 15. And then the u, you need to find the magnitude of it. So square of 5 is 25. And then square of 2 is 4. So this is square of 29. And do the v. 3 square is 9, 0 is 0. So you still get 9 here. You guys all right here? Okay. Now, then what you do here is move the cosine over. So first thing first, because this one wants in radian, so make sure your calculator is in radian, and then put down the arc cosine, because when you move the cosine over, it's arc cosine. Parenthesis 15 over by another parenthesis. This is the one that a lot of students make mistake, is they forgot to put an extra parenthesis. You know what? You do not need to. Let's erase that extra parenthesis. So we do not need that fellow. Can someone tell me what's 29 times 9? Anyone have a calculator? That will be quicker. What's 29 times 9?
261.
260. No, 29. Sorry, correct. 261. So leave your answer as root 261. Don't change the decimal. So take out your calculator, class. Change your rate, your mode in radian. Do the arc cosine of 15 over root of negative 261, and that will be your answer in 2 decimal place. You guys all right? Make sure your mode is in radian. Radian. Arc cosine of that. Square root of 261. 0.38. 0.38. You guys good with 0.38? So mostly the rest of the questions that you guys have is almost the same as the one that we did here. 16 is asking the same thing. Again, they have it in radian. 17 is also asking the same thing. 18 is a little bit different. The reason why 18 is a little bit different is because this time your U and V is not in the IJ form. It's in IJ form, but it's in the cosine sine form. So it's gonna be the same. I can tell you it's gonna be the same thing. So so how do you find the theta for number 18? So again, we do the U dot V. So you have to multiply these two up. So this is gonna be cosine pi over 4 times cosine pi over 4, 5 pi over 4. So you will get cosine of pi over 4 times with cosine of 5 pi over 4. And then you add with this sine pi over 4 times sine 5 pi over 4. Because it's this multiplied plus this multiplied. Can someone name me an identity that use this, that have cosine times cosine plus sine times sine, cos sine sine? We have an identity of this that you guys learned before spring break.
Sum and difference.
Of sine or cosine or tangent. Sine, sine, cos, cos.
That'd be sine.
Okay, so no, this is cos. Cos,
Oh, I
cos
see.
u minus v,
Okay.
right?
Yep.
Is cos plus sine, right? So what you do in this case is we just subtract this. So what is cosine of pi over 4 minus 5 pi over 4?
Negative pi.
Negative pi. Very good. And do you remember what happens for cosine if you have a negative inside the angle? Is a negative disappear or you put it up front?
You put it up front. For
Cosine? Yeah, for
What
cosine.
disappears? It goes away.
Yep, you're correct. So make sure you know all this when you go to calculus. So for cosine, this is the only one that go disappear is cosine. The sine and tangent is the one you move it up front. So this, and can someone tell me what is cosine pi is?
-1.
-1. Cosine is x, right? So so what we are doing here is just this fellow, which we get -1. Okay. Now we need to find the magnitude of u. So magnitude of u is you square this fellow and you square this fellow, right? Okay, so to find the magnitude of u, you have to square cosine. So I'm gonna start a new one. So we found the top one is a -1. Don't forget this is equals to cosine theta. Okay, not theta. Then we do the square root of this square plus that square, right? So it's cosine square plus sine square. And this one you should know this very important identity. What is cosine square u plus sine square u?
1.
1. So, and we know the square root of 1, this is 1, and the square of 1 is still 1. Okay. The good thing about this is u. The v is also same because you square this plus the square this. You also get cosine square u plus sine square v. This is also equals to 1. This is good news because that means that this is 1, this is also 1. So 1 times 1 is 1. So what is this going to be is cosine theta is actually is -1. Okay, because when you so this is actually when you square this you get 1. Then can someone tell me what is this angle will be in radian?
Pi.
Yep, thank you so much. We just did just now. Next, this is the same thing, but you just need to, but this is no longer in radian, this is in degree. Okay. The vectors, this is also same thing. You just need to do the this is they give you three vertices of a triangle. You have to find the angle. So what you do is you do the dot for the first one. You take these two pairs and you do it. Let's do this together. This one is a little bit 12, number 20. So you got the -9, -9, 3, 7, and 8, 4. So they give this in a vector form. No, this is not in a vector form. This is in coordinates form because vector is that little less than or greater than. So, so that means that they give you the coordinates -9, -9, 3, 7, and 8, 4. 8, 4. Sorry, my brain is a little bit off a little bit today, but I think I know where's 3, 7 at. So 3, 7 is up here, and 8, 4 is way down there. So they give you these three coordinates. So what you need to do first, anyone know what to do first? Thing to do? They want you to
Magnitude.
magnitude, yes. So you have to find the magnitude of this. So anyone know how to find a magnitude?
Okay, for the first side, you do -9 times 3 squared.
Negative. That would be wrong. Don't forget, these are all coordinates. This is not vector. You know what I'm talking about? These are coordinates.
Oh, so we don't use that.
We cannot use that yet.
Okay. So do we change it to vectors?
Yes, you have to. Do you know how to change -9, -9, and this is 3, 7, and this is 8, 4. There are 3 vectors here. There are 3 coordinate points. These are, you have to find what is vector. You have to, do you know how to do u, v, and w? How to find a vector u, v, and
Is it
w?
3 minus -9.
Very good. So in order for you to find a vector u is 3 minus -9, which is 12. And what?
And 7 minus -9,
Which is
16.
16. Thank you. That is correct. And then you find the vector v. Same thing as what you just did.
So 5 and -3.
Mhm. And then vector w. So draw the picture. I would really suggest you before you which is this.
Well, which way is it going? Down or up?
Very good. So yes. So this one you take this one is going this way. Let me see. You're going. This one looks like you're going this way because you're taking this minus that, right? Yep. This is your. And this one you're going this way because you're going. Is that right? 8. No. You're taking the other direction. So now this one, we're gonna go this way then, because you're following the.
Yeah. Okay, so that one's gonna be -4 minus 8, which is
Where's
-12.
-4? It's 8, 4, and 9.
9 is that 9?
Sorry, that's
-9.
9. Sorry, that's my bad. -9.
-9 minus 8, which is -17.
-17.
And then -13.
-13. This one looks like you're going to the wrong direction. Oh yeah, you're correct. Sorry. This one looks like going this direction. Oh, that's sorry about that, because the 12, 6 looks very positive to me. So positive usually go, I think this one you go this direction. 12, 16 is this direction. And let's do it the another way, because 5, yeah, 5, this is correct. 5, 3 goes. So if you do 12, 16, the vector u is go this direction. The reason why it goes this direction is because of these two numbers are positive. 5, -3 goes into quadrant 4. So it go down this direction. So this will go this direction. So you just need to change your sign in this case. So instead of -7, so should be +17 and +13.
Okay.
So it will nicely. So this is go back to the first. And then what you do here is figure out alpha, beta, gamma, or ABC if you want it easy for you. So alpha is using U and W, right? And then you're applying the same formula as the one that we just mentioned. So this is just more work here because it takes longer time. So alpha is between U and W. So we do the dot products between U and W. So it is U dot W, the magnitude of U and the magnitude of W. So you just take these two and do it. And then after that, you just need to do another one, which is, this is for alpha. And then for beta, you will be using U and V. So you just do these two to figure out your beta. And then the last one, the gamma here, you just take 180 minus alpha minus beta, because the whole thingy is 180. So you just subtract them out. You guys all right here? This question is not coming up in your test, so do not worry about it because it's a bit more work here, okay? More involved. The rest is pretty much straightforward type where they're asking us if they are orthogonal or not. So you just need to dot that and see if they're equal to 0 or not. If they're equal to 0, then you say it's orthogonal. Otherwise, it's not. There is also another formula, which is number 21, that I want to point out is this formula can also find the u dot v by multiplying the magnitude u and the magnitude v to the other side. So if you do u dot v is also magnitude of u times magnitude of v times cosine theta. So this is the alternate form for dot product. I didn't highlight this in yellow is because it's not as important. So this is only used if you know the magnitude of u, the magnitude of v, and the angle that forms between. So this is only used for question number 21, where you know the magnitude of u, and you know the magnitude of v, and you know the angle theta that form between u and v. So if you want to find u dot v, you simply need to just multiply them. So this, and then put the theta is cosine. So forget because it's a cosine here. So your answer for number 21, if you want to do this, is just you take 6 times 16 times cosine of pi over 3. So this is how you do, then whatever you get your answer is will be your u dot v here. So this is the alternative form, but again, it's not important. The most important thing that I want to point out to you is just dot like what I teach you earlier. Okay, that is important. This is just an alternative form, so not to worry about much. Next, now we're going to talk about projection. So this is something that if you go for physics, this is where you figure out how you figure out your force that you try to so where vector is force in physics usually. So when you we will break this into what we call as a vector component form. So you have the two vectors u and vector v is a non-zero vector such that u is w1 and w2. So this vector u is a w1. It consists of two vector form w1 and w2, where these two w1 and these two vectors are orthogonals, means they form 90 degrees. And w1 is actually r cosine theta, and w2 is r sine theta. The reason why is because of that what you guys learned in your last 8.3, that your horizontal component is always in the cosine. Your x, remember, your x is r cos, is always in cosine, and your y is in sine. So that's why your horizontal component, your w1 is in r cosine theta, and your w2 is r sine theta. So these two components is so if you want to write a vector u that project onto the vector v, and v in this case is actually parallel to the vector vector wi here, is called as w1 is the projection vector u to v. Don't worry about much more about this because we use this as a lot in physics, as so they just call the w1 here is the projection of u to v. Okay, and what is w1 and w2? These are the separate different two components. These two components are orthogonal to each other, and the w2 is u minus w1. So how do you find this projection u onto v? Is you have to use the dot product u dot v over by the magnitude of v squared times v. This if I give a test that is not a take-home test, this formula is already given to you. So you do not need to memorize this. This is one of the most difficult formulas to memorize. So I hate to memorize this formula. What is this projection W1 here is example is like a force. So imagine that you park a car. This is what you will see in your homework. So imagine you park your car on a cliff or on a, so this is your car. There is always a gravity force, and that is also your car will roll down, right? Because if you, this is a theta. So so this is actually is what we call as your R sine. This is your W2. Okay, because it goes up, and W2 is your that goes up and down. This is actually is your U. Your W1 goes perpendicular or 90 degrees. So this is kind of like so anything that force that has used gravity that will pull down something else, and you try to go against or go for it and something like that. This is where the projection U onto V is used. This is the main part of why you're learning this, is because of physics mostly. So this is the formula that we'll be using here, is where the U dot V, and then you multiply by the V's, the magnitude of V squared times the vector V. So it's a vector, and I will show to you what is useful for this in your homework, and definitely we'll talk about. We just mentioned this now. So so example here is you got you want to find a projection on U onto V, like question 25. So they give you these two vector U and V in this case, and in order for you to find the projection U onto V, you just need to use the formula that I provided to you here. Okay, so I will show it to you how to use this formula. So projection U onto V is actually U dot V, and then absolute value of the, not absolute, the magnitude of V squared times V. And so in order for you to find this question, number 25, you will find the U dot V first, and then after that you find the magnitude of V's, and then after that you multiply by the vector of V. So let's look at this. So U is 3,9, and a V in this case is 6, -2. So in order for you to find the U dot V, so again, you multiply this. So 3 times 6 is 18. 9 minus 2 is also 18. So this is very easy because you do not need to find the rest of it, because 18 minus 18 is 0. And anything divided by 0 is going to be 0 divided by anything is 0. So your answer in this case will be 0. But do not forget, this is a vector V, so it is a vector form. So your answer in this case is 0, 0, or if you want to write 0, like what we did last time, it's the same thing. And then to find the sum of these two out, so it's very easy. Is U in this case is W1 plus W2, but so you just need to subtract this number in order for to fill this in. You just need to figure out, this is going to be 3,9. This is easy because the U is already 3,9. This is 0, 0. So I'm going to show you another. This is too easy. The reason why I'm saying this is easy because the product of this is 0. So let's say this is -1. because in your test, you won't get 0, 0. So this one might be a bit different then. So I'm going to change that value to -1. So now it's not -8, it's -9. This is better. I'll just show it to you this way so it's easier. And then the magnitude of v in this case is the square root of 6, which is 36, square him. And then 1 square is 1. And then you square him, because don't forget, you still have the square involved here. And then after that, you multiplying, this is a scalar. This whole thing is a scale, it's a number. You're multiplying with v, which is 6, -1. So once you multiply with the vector, this is a vector. So the square and square root here will cancel. So 18 minus 9 is 9. This is 37. And then this is 6, -1. This is a vector v that I have. Some of you are wondering where I get this number. This is a vector v that we have. And then you just distribute this 9/37 over there. So this is almost the calculator stuff. That will be 54. 9 times 6 is 54. So 54 over 37 and -9 over 37. So this is your answer for the projection v, u to v. This one instead of 0, 0. Okay. I just changed the number a little bit because your test will look something icky like this. And then usually I also want you to find what is this W2, this blank, this 39. So in order for you to find this, you just need to take u minus whatever you have here, your answer that you have. So u in this case is 39. And you minus with this 54 over 37 and -9 over 37. So calculators you need. 3 took away 50. You guys know your ABC button in your calculator, right? Please use that wisely here because that will help you. So this is 57 over 37 for the first component. Second component is 9 plus, because you got double negative, so it's 9 plus 9 over 37. This is 342 over 37. So these are the two answers we are looking for. So that means that if you add these two up, if you add, this is your W1. So if you add your W1 and W2 up, you should get 3/9. Okay, so if you add your W1 and W2 up, you should get the U here. Okay, so what they're going on here is, if you're talking about this car, they will split this car into two different vectors. W1 vector is this vector that stops the car from rolling downwards. W2 is the vector that force that pull down to the gravity. So these two vectors are like, they're split into two. So so that's the reason why that in order for you to stop the car from moving down and all these things, again, this is just an example. This will break into this two component form. And the W2 form is this, how you get this. And the W1 is how we usually is using this formula. Okay. Again, you have to take physics, which is a very difficult class when you go up to force here in order for you to get. So if I do this, then this is your answer for the first box, and this is your answer for your second box. Okay. So this is 8.4 where we talk about dot product. So mostly what are important in this case I want to point out to students is the dot product is useful for 3 things. One, to figure out if your dot are orthogonals or not, the 2 vectors. 2, to figure out the angle between 2 vectors. And 3 is this one, the projection U onto V. So so that's the 3 things I can point out to you guys when you guys do the dot product. That we're doing what we call is the applications of vectors in this case. Okay, and then 8.6 is the last section that we will talk about here. Again, please get my notes in D2L here that mostly your homeworks have it. Is what we call as a trigonometric form of a complex number. So we will talk about complex plane now. We talk about complex number, so we talk about complex plane. So complex plane is actually consists of 2, like an X and Y axis, but we don't call it X and Y axis. We call it a real axis, and we call it as an imaginary axis. So usually your X axis, your horizontal axis is the real, and the imaginary axis is your Y axis. Okay, so when you have example is if I want you to draw 5 minus 4i, this is complex numbers, in a complex plane, how do we draw this? This is 5 is real, and minus 4i is your imaginary. So this is your 5 minus 4i. So it is in right over here. Okay. So why this is important is because of it is the quadrant. Okay. I will point out later on why this is important. So the distance from here to here is called the R, the radius. And then the angle theta is called the R is a modulus, and theta is called the argument. So so this 5 minus 4i can be written down as R cosine theta plus I sine theta. So so any complex number can be written down in a trig form. This is a trig form where R in this case is the radius of it, and theta in this case is the angle forms. Okay. How do you find the R? In order for you to find the R, is like your like vector. You do the magnitude. So it's a squared plus b squared. So this is your A, and this is your B. Don't forget your B can be positive. A can be positive, negative. B can be positive, negative. And how do you find theta? Because which is in here, right? The code. In order for us to do theta, is you do tangent theta is B over A. So this is the important formula to find your R and your theta. And the reason why I point out again and again and again that be careful with this one is because it depends on your quadrant. This is important, and this is where a lot of students get wrong in my test, is because the quadrant is wrong. For example, now this one is good because it's in, okay, we'll do this, and then after that I will tell you what happens. A in this case, so in order for us to change this into the trigonometric form, 5 squared is 25. And B is 4, 4 squared is 16. So 25 plus 16 is the square root of 41. And then to find your theta, I just move my arc over there. So it's B, which is negative 4 over 5. And you do the arctan of it. Some students ask me what mode you want. Usually I want it in degree. I think your homework also wants it in degree. So change your calculator back to degree. And if you do the arctangent of negative 4 over 5, it came out to be negative 38.66 degree. And this is where the quadrant plays an important role. Does anyone know negative 38.66 is what quadrant? And what is the quadrant of this? Anyone know what quadrant is this point at?
4.
This is in quadrant 4. And where is negative 38.66? That is also in what? Quadrant 4. So that means this is the correct quadrant with the correct point. So your answer in this case will be square root of 41. Now this is where the shortcut comes because I'm lazy to write cosine theta plus I sine theta. I will put the CIS, negative 38.66 degrees. Okay. The CIS stands for cosine plus I sine, and it's always cosine plus I sine. Okay, you cannot change that. That's why we use the CIS symbol. Now, what happens if I change this to negative 5 plus 4i? Now, you will still get 25 plus 61. We still get root 41. But unfortunately, you cannot use this over here. Okay, you cannot use it. And the reason why is, can someone tell me where is negative 5 plus 4i in this picture? What quadrant? This is negative 5. And this is 4i. This is in quadrant 2. But you told me this is in where? Quadrant. You will still divide this 4 over negative 5. You still get the same number. But unfortunately, this is in quadrant 4. So can someone convert negative 38.66 from quadrant 4 to quadrant 2? Anyone know how to convert 4 to 2? It's a direct straight line. What angle is this?
Is it 141.34?
How you get that number, Summer?
I added 180.
You are correct. So it's very easy. So in order for you to change from 2 to 4 or 4 to 2, or you just you add 180, okay? Or subtract 180, depends on. So Summer, what can you say again? 100 and what? 40 what?
141.34.
Yep, this is correct. So this is the thing that I want to point out. Very good. So a lot of students make mistake in my second test is because they forget to convert from quadrant 4 to 2 or 1 to 3 or something else like that. So make sure you guys draw this picture to figure out what to know what quadrant is the correct quadrant. I'm also taking attendance. So can you please put your name for attendance? So, so this is how we convert from complex to what we call as the trigonometric form. So once you do this, then we can do a lot of things, like we can multiply these two. So we can multiply these two up. So for us to multiply, it's very easy. You just need to multiply the modulus and add your angles. Okay. So if you have, when you multiply, you need 2, right? So if I want you to multiply 41 CIS 1431, square root of 41 with this, with a square of 41 CIS. So I want you to multiply these two trigonometric form here. So what you do here is you just multiply this. So root 41 times root 41. And then what you do with this is you just add your angles up. Negative 38.66 plus 141.34. Because that one is negative, so we have to subtract actually. So in order for you to multiply this, you just multiply these two up and then add your angles. The good news about multiplying with the same square root, root 41 times root 41, you end up with 41. And then what you do with these angles is you add them. So 141 plus 34. This one is subtract because it's one of them is minus. This one came out to be 102.68. So if I want you to multiply these two trigonometric form, it's very easy. You multiply the numbers, you add the angles. Okay, this is how you multiply two trigonometric. We call it the complex number. If you want to divide, it's also easy. We divide the numbers, but we subtract your angles. But when you subtract, make sure you subtract from the top, from the bottom. Okay, so for this, if I want you to divide these two, so what you do is you take the root 41, you divide it, which you get 1 in this case because they are the same. And for the angles, you subtract it. So negative 38.66 subtract 141.34. So this will cancel out, become 1. And then you need to, instead of just minus these two up. So 38.66 minus 141.34. So that will actually is net 180, negative 180 degrees. So this is the properties of having, when you get into this form, when you multiply and divide, you simply multiply the numbers and add or subtract, add the angles. When you divide the numbers and you subtract the angles. So this is done when you do 8-6. So example is, I think you know how to draw this. What's that at? Where was that at? Like this one. So they want you to multiply these two trigonometric form. So can someone tell me how we multiply these two trigonometric form? Is the number 6, 7, and 7, you multiply it. Does anyone know what 6 times 7 times 7? 6 over 7 times 7. You'll get out with 6. And then you will get the CIS. And I want to point out to you that your online homework do not like CIS. So you actually have to type out that same way as they written down. I'll show it to you. And angles, you need to add it. So you have to take pi 6 plus 6 pi over 7. You guys know how to add these two angles up? So pi over 6 plus 6 pi over 7. That will give you what? 1 over 6 divided by what? That plus with 6 over 7. 43 pi over 42. So this is going to be 6 times cosine of 43 pi over 42 plus I sine 43 pi over 42. So the 6 comes from the multiplying of 6, 7, and 7. The 43 pi over 42 comes from adding pi 6 and 6 pi over 7. You guys all right here? This one is even, radian is a bit tough because it is, oh, by the way, yeah, this is correct because it's, make sure you read it because it is between 0 to 2 pi. This one is, degree is even easier. You just need to add them. So multiply the fraction, the number first. So 2/3 times 4/5. 2/3 times 4/5 is 8/15. And then, course, for the angles, you need to add because you're multiplying, be adding. 300 plus 110. So 300 plus 110 is 410 degrees. However, the 410 degree is over 360. So can someone convert 4/10 degrees into 0 to 360? What's 410 into 360? 0 to 360. 50, right? You just subtract 360, you got 50. So your answer would be 815 cosine 50 degrees. Oh, where's my friend degrees? You need to put that degree symbol in there. They're very picky. I want to point out to you guys. I think it's under, yep, that's my degree symbol. Plus I sine 50 degrees. Make sure you have the degree symbol. So this is how we do this kind of questions. So maybe there's extra, maybe there's an extra parenthesis there. So watch out for all these parentheses. Yep. So make sure you guys, when you multiply the numbers, you add the angles. When you divide the numbers. So like here is 1/4, and then here you subtract. So 140 minus 10 is 130. So your answer in this case will be 1/4 times cosine of 130 degrees. Don't forget the degrees. I don't have time for that. Plus I sine 130 degrees. Okay. So don't forget you take the top one minus the bottom one. Now this is for the when you divide. Okay. This one you have to convert this into the cosine I sine first before you do your work here. Multiply is the next one. So when this is called the De Moivre theorem. So when you have it into the powers, the De Moivre theorem says that if you have it into the powers, your R will be in the power of n, and your angle will be multiplied by n. Okay. So what does that mean in this case? Is it means that if you have like this, because this one you have to convert into the trig form first. And once you get into trig form, what you do with the De Moivre theorem is the number 4 here will be power 4. And then your angles, you multiply by 4. So 60 times 4 is 240. Okay. Use your calculator and figure out what is 4 to the power of 4. 256. So this is actually 256 cosine 240 plus I sine 240. It's very easy applying this theorem. The only downfall is you can only apply this theorem in trigonometric form. So if your question is in a complex form, you have to change it into trig form using the formula I showed you early on, that square root of a squared and b squared, and the tangent theta is a over b. You have to use that in order for you to, once you convert into your trigonometric form, then using De Moivre theorem is very easy. You just power it to the number, the angles you multiply by 4. Like this is very easy. Does anyone know how to do this one? Using De Moivre. This is already in the trig form already. Oh, they want in standard form. They're tricky. I'll show it to you what happens. This one is wrong because it's not in the standard form. 2 to the power of 4. Cosine of what? Well, it's half times 4. Two pi plus I sine 2 pi. Anyone know what 2 to the 4 is? 2 times 2 times 2. This is actually 16. Okay. This is not standard form. So how do we convert this into standard form? Is take out your calculator and multiplying. What is 16 times cosine 2 pi? You guys got your mode? Cosine 2 pi is a whole 360. So cosine 2 pi is 1. So this is actually 16. And sine 2 pi is 0. So 16 times 0 is 0. I. So your answer in this case is just 16 because the I is 0. So your answer for this is 16. So this is what they want, is they want it in a standard form. Same thing happens to this. They want a standard form. So you take, remember the unit circle that you guys learned is back again. So like cosine 240, you have to use a unit circle to figure out what is cosine 240 is. And then multiply it 2 pi over 6. And then sine 240, what is sine 240 is. Then multiply it with 256. So the last formula that I did not teach is going to be what we call as finding the nth root. This is given us by this horrible formula. Yes, this is one icky formula here. This formula is to figure out the power of finding the nth root of a complex number. So I would recommend you to watch a video. Yes, I do have a video for this, applying this last formula here. So this section 8.6 is not difficult. The only difficult part is watch what quadrant it belongs to, because it has a domino effect. If your theta is wrong, everything is wrong. Okay. So I am going to end today's Zoom meeting here. So 3:30. So if you have any questions, let me know. You do have a test next week, which will be at 8.6. So you will have so you don't have any Zoom, but if you have any questions, please let me know. I'm actually late for my other class, Zoom class already. It's 3:30. Anyone have any questions here?